unfortunately, the computation of the integral is not as straightforward as you may think. Like you have to find the antiderivative of a given function. Well, I know how to do it. Take that function, just write integral around it, and here's what we want, right? It doesn't work this way. So when you compute in practice, you really have to do some work. You really have to use calculus 1. So let me do an example. And I will not do a simple example as you practiced for the homework. I will find an integral from -2 to 3 of the function. Here, let me start with a simple one. X cubed dx. So what do you do to find that? You figure out what the function is that has x cubed as derivative, right? So you guess that x to the power 4 should be something, but derivative of x to the power 4 is 4x cubed, and 4x cubed is not quite x cubed. So if you pre-divide x to the 4th by 4, the output will be exactly x cubed. So this is the antiderivative. And I'm not using either first or second parts of the fundamental theorem of calculus here. I'm doing calculus 1 guessing about what antiderivative is. And once I've done that, I can use this together with the first part, that part of computation of the integral. I have to take this function, I have to evaluate it at 3. It will be 3 to the power 4 divided by 4. Then I have to evaluate the same function at -2. And then the rest is computation. And I will not do it. Delegate it to Wolfram alpha, if you want. Now, a more interesting example is an integral from -2 to 3 of a function absolute value of x cubed. Now the problem here is that you probably don't know what the antiderivative is of this strange function with absolute value. So you may want to guess to figure out the formula, but I don't know if you succeed in that or not. What I would suggest at this point is to get rid of the absolute value. And the way to get rid of absolute value is to say that absolute value of x cubed is what? Just to explain what absolute value is. It is either x cubed if what? If x is positive, or negative x cubed. That's right. If x is negative. So this way we come to the concept of partially defined function. A function is defined by different formulas on different parts of the line, of the domain. And now, of course, this integral from -2 to 3 doesn't belong to, well, completely to any of those two parts. So what we can do is we can cut this interval into pieces, and we use additivity. So I use additivity of the integral here. And my equality becomes longer. But I will integrate from -2 to what? 0. To 0, exactly. And of course I'm integrating still the same function. That's the value of x cubed. And then I integrate from 0 to 3. So I'm not doing much in the sense of computation, but I'm in preparation for the computation. Now I say that over the interval from -2 to 0, my function has a much better expression. It is minus x cubed. So I simply continue this computation saying the first integral is integral of minus x cubed from -2 to 0. And the second integral is integral over the interval where my function is equal to x cubed. And then we proceed with standard computation like this one.